Hey Alex, hope you're doing okay. All right, so polyatomics. First of all, let's talk about what a polyatomic is. A polyatomic is an ion that has more than one type of element to it. If you look up here, I have iron chloride. Down here, I have iron sulfate. So which one do you think has a polyatomic ion in it? Yeah, the iron sulfate, because it has iron and then sulfur and oxygen. The iron chloride and the iron sulfate are similar in the way that the compound is structured. I've got two chlorine atoms up here, and I have two sulfur ions here. Now remember, when you have a compound, you have a positive ion joining with a negative ion because the positive and negatives cancel out and make a neutral compound. Down here, the iron again is always positive, and the sulfate here is the negative ion, but the entire sulfate is the negative ion. Okay, so let's talk about balancing. I'm going to balance this one since it's very similar to this one first. Metals, polyatomics, nonmetals, hydrogen and oxygen last. So iron and iron. I have one iron here and one iron on the product side, so we're balanced for iron. Let's take a look at chlorine. Two chlorine atoms on the reactant side and two on the product side. Not balanced. I need two on this side. So in order to multiply to get 2, I'm going to put a 2 as my coefficient in front of the chlorine. So double check. Got 2 on the reactants, 2 on the products, and then 1 iron on each product and reactant side. The last thing you do is add a 1 in front of the elements that we didn't have to do anything to balance. Okay, so yay, so we're done with that one. Let's look at one with a polyatomic. Okay, again, we're going to start with our metals, which is iron. 1 iron atom on this side and 1 on this side. How many sulfate ions? How many sulfate ions on the reactant side? 2, right? And how many on the product side? Just 1. So if I want to balance for my sulfates, I have 2 on this side. I need 2 on this side. I can put 2 in front of my sulfate. Now the reason you can balance polyatomics is because you have the entire SO4 ion on both sides. And why you do it is just a time saver. You can get the same correct answer if you balance for iron, sulfur, and oxygen separately. It just makes it faster if you balance the polyatomic all as one. Okay, and then, oh, I forgot something. I've got to put my ones in. Okay, so that's an easy one. Let's do one that's a little more complicated. And I have to do it on a clipboard because it was too big to fit on the whiteboard. So can you see that? Hey, Colin, I'm busy. All right. I've got this equation. I'm going to hold it so you guys can see it. And put it on the floor. Sorry, I don't want to stop this and redo it because it'll take too long. Okay, so I have my equation. Iron nitrate plus magnesium oxide yields iron oxide plus magnesium nitrate. This is just a double replacement reaction where the two reactants switch places.
Yeah.
So really, this is getting too long. Okay, so now what we're going to do is we're going to do the same thing. Metals, polyatomics, nonmetals. And our metal down here is, we have 2, magnesium and iron. I'm going to do it in my head again without the table, just because I think that's the way that you like to do it. And we'll come back together and do it with the table if we need to. Okay, so let's look at just my irons here. I have 1 iron on the reactant side, and I got 2 on the product side. So in order to make this be balanced, I need 2 on this side, and I'm going to go ahead and put my 2 coefficient in front of the entire iron nitrate. Okay, so my irons are balanced. Now let's look at magnesium next, since it is another metal. I have 1 magnesium on the reactants and 1 on the products, so we're okay for that for right now. Now we move on to our polyatomic. Our polyatomic right here is this entire nitrate, and we have over here. How many entire nitrate ions do I have? On the reactant side, I have 3. That's a 3. And then on the product side, I have how many? 2. Those guys are not balanced. But, oh, wait just a second. Remember how I put that coefficient in? That means that you have to multiply the 2 through the entire compound. So instead of having 3 nitrates, I have 2 times 3, which means I have a total of 6 nitrate ions on the reactant side. Over here, I've got only 2. What can I multiply 2 by in order to get a total of 6? Right, 3. So I'm going to put my 3 that I multiply by as my coefficient. So now let's double check. 2 times 3 is 6, and 3 times 2 is 6. Okay, so now I'm balanced for my iron, my magnesium, and my nitrate. So over here, when you do the oxygens, so now I'm going to go back though, because my oxygens, you say I have 3 here and have 1 here. If you look at the oxygens, I have 3 and I need 3. I can multiply that 1 oxygen by 3 and do this. So now I have my 3 oxygens. I'm going to double check my magnesiums. How many magnesiums do I have on the reactant side? Yep, I've got 3. And then on the product side, oh, I have 3 as well. So I'm going to actually write down all of the ones and make sure that we are completely balanced, since it's a long problem. I've got 2 irons on the reactant side. I have 2 irons on the product side. So my iron is balanced. My magnesiums, I have 3 now, because of the coefficient, on the reactant side, and I have 3 on the product side. So my magnesiums are also balanced, my 3 and my 3. Lastly, the last one we're going to check is our oxygens. I have 3 oxygens, and I have 3 oxygens. So my oxygens are balanced. And we had already double checked, I've written down that we had 6 nitrates on the reactant side and 6 on the product side. All right, so my NO3. All right, so that's a long one. I'm not sure if the problems in Khan Academy are going to be quite this long and time consuming, but they might be. So look at this, and then I'll give you a problem a little bit later on for you to go through. Okay, all right, hope that was understandable. Bye.